Okay, good morning, everyone. The last lesson for Chapter 7. We're going to look at simple transformations of the exponential and logarithmic functions. And in particular, we'll only be working with the natural base, or base e. So e of x, or the natural log of x. We'll talk about or describe the domain, range, and asymptotes, things that you will cover a lot when you get to pre-calculus. So let's begin with the basics. The exponential function, base e, y is equal to e raised to the x, which you see is graphed out there in red. Okay, so this is the function y equals e raised to the x. The domain for that function, we can use any x value. So the domain will be all real numbers. The range, however, notice again we have a horizontal asymptote. So that graph approaches the line y is equal to 0. I have a horizontal asymptote at y equals 0. So my range will be y is greater than 0. For the exponential function, the range will be y is greater than 0. So I'll have a horizontal asymptote, then I'll just call it HA as y is equal to 0. Okay, so I described the domain, the range, and the asymptotes for the exponential function. The inverse of the exponential function is the log function. In this case here, the inverse of e raised to the x is ln of x, the natural log of x. And you see it's graphed out there. Okay, so it's graphed out there. Now remember, the inverse function or inverse relation, you switch the x or y's, and you switch the domain and range. So this is the function y is equal to the natural log of x. So the domain for that function notice here I have a vertical asymptote right here. So that function y is equal to the natural log of x will never cross the y-axis. Okay, it has a vertical asymptote. So the domain of that function is going to be x is greater than 0. Is the remember the range of y is equal to e raised to the x was y is greater than 0. But then we switch the domain and range, so the domain for the inverse, or y is equal to natural log of x, will be x is greater than 0. And then the range then will just be all real numbers, okay? Which was the domain of y is equal to e raised to the x. Again, we switch the x and y's, we switch the domain and range. And then I have a vertical asymptote at x is equal to 0. So that's my vertical asymptote, x is equal to 0. Okay, so that's the simple case. Not that it's going to get too much more difficult after this here. So know the domain and range and asymptotes of the natural log functions as well as base e. Now we'll make simple transformations. All right. So let's say here I shift the exponential function up by 2 units, right? So if you notice here, it hugged the x-axis, or my horizontal asymptote was y is equal to 0. So now I'm just going to shift the graph up 2 units. Notice here I have plus 2. So I'm just going to shift that entire graph up 2 units. So again, my domain will still be all real numbers, but now my range is going to be y is greater than 2. Okay, I shifted my horizontal asymptote up 2 units, and so my horizontal asymptote now is y equals 2. I've shifted the horizontal asymptote up 2. Well, how do we find the inverse function for y is equal to e raised to the x plus 2? Okay, very easy. Okay, to find the inverse, again, remember we switched the x and y's. And so I will write y is equal to e raised to the x plus 2 as, so this is what you do to find the inverse. To find inverse, switch x and y's, and then solve for y. Okay, so what I mean, so I started y is equal to e raised to the x plus 2, so now I'll go x is equal to e raised to the y plus 2. I want to solve for y, so I have to subtract 2. So this will be x minus 2 equals e raised to the y. And then to get rid of e, I'll take the natural log of both sides. So the natural log of x minus 2 equals the natural log of e raised to the y. Well, that just cancels out because they're inverses of each other. So then the inverse function will be y is equal to the natural log of x minus 2. Or we would say here x minus 2 equals, and we use that notation to represent the inverse. So that's the inverse of y is equal to e raised to the x plus 2. The inverse would be the natural log of x minus 2. X minus 2. Which is graphed here. So this was the function y equals e raised to the x plus 2. And then the inverse function will be y is equal to the natural log of x minus 2. Okay, remember, keep in mind here the domain of a log function, it can't be negative. So you see, so you see I have a vertical asymptote right here. I have a vertical asymptote there. So the domain of that function will be x is greater than 2. Can be 2 because 2 minus 2 is 0, and you can't take the natural log of 0. So the domain has to be x is greater than 2. The range again will be all real numbers. Okay, and so I'll have a vertical asymptote, and x is equal to 2. So let's just compare. So for y is equal to e raised to the x plus 2, my domain was all real numbers. That will become my range of the inverse. The range for y is equal to e raised to the x plus 2 was y is greater than 2, so that will be my domain for my inverse, so it will be x is greater than 2. And then my vertical asymptote is x is equal to 2. Okay, and then one more of these here. So let's say here I start with the equation y is equal to e raised to the x plus 3. So basically I shifted the y is equal to e raised to the x down by 3. So you'll see that my horizontal asymptote now will be at y is equal to negative 3. Y is equal to negative 3, and here's my function y is equal to e raised to the x minus 3. Okay, so again, the domain will be all real numbers. The range now will be y is greater than negative 3. And then I'll have a horizontal asymptote at y equals negative 3. Y equals negative 3. To find the inverse of y is equal to e raised to the x minus 3 again. We have y is equal to e raised to the x minus 3. We switch the x and y's, so x is equal to e raised to y minus 3. Now we solve for y, so we have x plus 3 equals e raised to y, and then we take the natural log of both sides. X plus 3 equals the natural log of e, oops, that doesn't look like an ln, so the natural log of e raised to y, and of course that cancels out. And then we're just left with natural log of x plus 3 equals the inverse. So this is the inverse function, so y equals the natural log of x plus 3. The domain, okay, again, remember for y is equal to e raised to the x minus 3, the range was y is greater than negative 3. So now the domain will be x is greater than negative 3. x is greater than negative 3. I have a horizontal asymptote, which you can see there, and x is equal to negative 3. X is equal to negative 3, so that's my domain. My range is just going to be all real numbers. I can use any x value. And then my vertical asymptote then will just be at x equals negative 3. Okay, so those are the simple transformations of the base E. So just know how to find the domain and the range and the horizontal asymptotes and to make those simple transformations. Okay.